All right. Okay. So, good morning, everybody. My name is Falk Wagner. I'm connecting to you from Germany. I have to make a confession. So I'm maybe one of the more complicated speakers for the summit today. The first item is due to COVID-19, I could not make it to Sao Paulo in person, and I'm very sorry for this. And thank you very much for the opportunity to connect to you online today. And then the second item is that my Portuguese is so poor that Melissa and her team had to offer me to do the speech in English. So thank you for this as well. Now, I hope this is going to work for everybody in terms of language. The slides I have prepared, I have really prepared them for you to hopefully have a takeaway. So I would like to ask you to please, interrupt, ask questions if something is not clear, if I'm moving too fast. I love interactions with the audience, so never be shy, please, to ask. The speech I have prepared for today is about machine learning, and on the one side about theory, on the other side the practice. So I'm trying to bridge the theory to some very concrete use cases, and I hope that's going to be interesting. I would like to start with a very brief introduction about myself. I've been in credit risk management for over 15 years. I've worked for telecommunication companies like Deutsche Telekom or T-Mobile in the US and British Telecom in the UK. I think telecommunication is very interesting because you have an extreme amount of data, lots of customers. So these are things that credit risk managers enjoy. More lately, I've been working in China with a large consumer financing company that is giving a loan to the aspiring Chinese middle class of people. And again, that has been very interesting because China has basically jumped from a cash economy to an all mobile payment economy. Now, most lately, China has gone through COVID-19 as any other countries, and so if you are stressed right now with payment holidays and how to well manage your customer base, I can connect to this. I have done work as part of underwriting, collections, and fraud, so basically covering many areas of credit risk management. And so you will see later that the use cases I have selected are trying to to touch all of these different areas. What I found as part of the work being done with these different companies is that a lot of the techniques that are coming from natural science and statistics can be applied to plenty of different areas of businesses. So there is a huge appetite for companies from different industries to make their business more smart and start leveraging big data. And so that is why my Sylvan Roth, who is with you in Sao Paulo, and Stefan Armanat, who's in Switzerland right now, myself from Germany, we founded a company called AABLE, which is joining the event today. AABLE is providing consulting work on analytics and scoring. We also helping companies to get funding from Europe for credit businesses in Brazil. Our focus is really around enabling lending. So if you are sitting on a large customer base, which soon you have built some trusted relationship, and you're looking for ways how to engage them in financial services and how to offer maybe loans to your customers, we might be a company that can help you with this. Over the years, we have built a very extensive toolkit for machine learning from alternative data sources. Now, one thing that we are really trying to move forward is the idea of fair lending. We're basically saying credit itself is always positive. It allows people to traverse the time and space of doing commerce, etc. Just the conditions have to be fair and the lending has to be very transparent. So we have launched an initiative called Right Lending. You can see the website's address down there. Murphy's Law, we were changing the vendor, or the vendor was changing a server last night, and we have a downtime today. But maybe you could check back if you want to learn more about this. All right, diving right into the discussion. I have prepared a presentation that has basically two components. I firstly would like to spend some time talking about the large trends in machine learning around predictive data and scoring. You will see that as companies are turning their businesses more digital, they are capturing many more data elements than previously, which is empowering them to optimize many aspects of their business holistically using data. And the other thing is that scoring has made big advantages as part of computing power becoming more cheap and more available, and so there have been changes there as well. Once we have spoken about these more theory-driven discussions, I would like to then dive into 4 use cases, which are going to be around credit scoring, how to move from credit scoring into profit scoring, how to leverage network analysis to improve your credit scores and maybe help with fraud detection as well. And finally, I would like to spend a couple of minutes on collection scoring and how it can be used for cash flow optimization. The whole speech has around about 10 slides. It should take us something like 30 minutes, 35 minutes. And so I understand we have reserved 10 minutes towards the end for any kind of questions or comments you might have, and I will be very happy to take them. Okay, moving into the first part, predictive data. So I came around a slogan very recently that was saying, data is the new oil. And I think many of us can connect to this. So we have seen companies that have had tremendous growth on the internet by capturing data and by connecting customers through some kind of business logic. So you might think of, obviously companies like Amazon or companies like Airbnb or companies like Facebook. These companies had huge success in collecting customer data and compiling profiles. And so what is true for e-commerce companies is also true for telecommunication companies, which are basically capturing a constant stream about our locations and what we're up to on our phones. And then we also have the new players like payment platforms. So you might have followed the discussion around WeChat that the United States would like to bar from making business in North America. And so WeChat in China is just everywhere. Literally, when I'm leaving the house, I don't have any cash on me, and I don't need cash for many weeks because simply you would pay with your phone everywhere. So as a consequence, these companies have basically broken the monopoly, the historic monopoly of the banking sector when it came to data for customer scoring and profiling. I remember moving into credit risk management 15 years ago, and for any kind of question, we would turn into banking data, confirm this customer exists at this address, banking data, spending behavior, banking data. Now, I think there is an opportunity to use different data sources, which in itself is good because it's turning your data more colorful. So it has a higher dimensionality. You capture much more about the customer behavior. Having said that, you can find that as new players are moving into the data, they might not be willing as readily as banks were in the past to share this kind of data. So traditionally, the banks have been very good partners of credit bureaus in exchanging data about fraud and non-payment. So you basically had a good coverage of this kind of industry. And so now this might go away, creating some blind spots. So you would want to spend, checking carefully what kind of data you have and where maybe you might have gaps. So data sources, I think, have become much more diverse. The second item is that because of digitalization and because of customer self-service, many companies are now capturing much more information about their customers. And now this capturing more data, I think, can be broken down into 2 parts. So the first thing is, as customers start to interact in a digital way with companies, the frequency and the amount of transactions that are being captured in the systems has increased. But then there is also a second class of information that historically has not been available. And I'm talking about call recordings, for instance. So some companies are sitting on this huge amount of call recordings they have to take for compliance issues, but they have not really been able to analyze them and understand what is in these recordings. Now, thanks to speech to text technology, you can turn this information, these recordings, into text to then do text mining to basically understand on a large scale what your customers are talking about when interacting with your company. So I think this is also a very good source of information, particularly, let's say you are tracking complaints data. So what is it your customers are complaining about? Are there any keywords in there for fraud that you would like to follow up on, etc. So I think there's a lot of opportunity there. Now, as companies started to collect more data on their own, I think they have put themselves in a very good position to compete with other companies more strongly. So typically you would find that internal information about your customer is more valuable than what you can buy on your customer on the market in terms of external data. And that is because this data is very concrete to your use case, very concrete towards your relationship with the customer. So it's really spot on when you think about what is the customer's behavior going to be in the future. So that creates, I think, an advantage for these companies to outprice external lenders eventually. Then the third big change that has been around predictive data is that a lot of data is now basically being self-generated by customers. So all of us are carrying these cell phones with us 24/7, and so they're basically collecting a lot of information about, who we are, what we're interested in, what kind of software we're spending our time on, but also if we get up early or late in the day, if we travel to work typically, or we work from home, all of this information. And if you can harvest it, if your customers allow you to read this data from the smartphones, again, that would be a very big source of information. So overall, the data environment has become more colorful, more information available, maybe also a little bit more complex to handle. Now, once you have all this beautiful data, you dive into scoring. And so I titled this slide, Scoring an Age of Opportunity. And so here's why. I was looking at computing power. So how does the pricing today of computing power compare to the pricing back a few years back? And I was very interested. I never realized that actually the price of computing power over the last decade has fallen by 90%. So crunching data, processing data has become much, much more cheaper. Then the next item is what is true for computing power is also true for storage space. It's much cheaper now to store all your information, which is explaining the appetite of companies to keep this data and put it into the data warehouse. So you have computing power, you have storage, both of it have become more cheap. Then the next item is software. There again, you might remember 15 years back, you would be using software from companies like SIS, SPSS, you would use maybe MATLAB. All of this excellent software, very well written, perfectly documented, but also fairly expensive. So there was some kind of fixed cost barrier for companies to engage in data science and engage in analytics. Now, today, if you look around on the Gartner research on analytics software, you have packages there from like R, Python, storing data in Hadoop. You have all of these open source software that is freely available. So it means getting into analytics has become much cheaper in general. Now, the second component is that the algorithms which are available in data mining today, or which are commonly used in data mining, are maybe more powerful too than what you had in the past. And again, I think this goes back to the availability of computing power. I give you an example. Artificial neural networks have been around for 2 decades, 3 decades. So this is well-known technology. However, it was computationally very expensive to use it. And only now, with the cheaper computing power being available, these algorithms have basically some kind of second, like a rebirth in the form of deep learning. So now all of these technology is used for image recognition, very complex models, but easier today to train than it was in the past. Another example from algorithms would be the strong performance that is reported for ensemble algorithms. And so these are algorithms where you would not program one model, you would not train one model, but you would train hundreds of models to then combine them into a very powerful kind of super model. Again, pretty computationally expensive, but easily doable today. So then, having said that, there are still struggles when you work with the data. So I was describing, everything has gotten cheaper, everything has become more readily available. But now, one of the issues is, if you're sitting on such large amount of data, you still need people to understand how to read this data. But that's what I call domain expertise. Then you will need people that are able to do the programming of your beautiful R packages, etc. And then you will need somebody to help you navigate all this pile of data to understand which pieces of information are actually valuable, which ones are the ones you should be looking at. And that, as data grows, becomes a more challenging exercise. And as a consequence, AABLE, for instance, has started writing specific software packages for this to automate this kind of job. But so having said that, still scoring age of opportunity. So I think there's much in there. All right. So once you have the data and once you have the scoring, let's talk about what you can do with these, with this kind of technology in credit risk management. So the first item I would like to discuss is credit scoring. And so from Melissa and the team at proScore, I know that basically you in the audience are all familiar with scoring. You're basically experts in it. So I'm skipping like the basic part. Instead, what I would like to reflect on is what we have learned when working on Brazilian data sets specifically. And so I'm breaking these learnings out into 3 domains. So predictive data, opportunities for feature engineering, and finally for the actual scoring. I start with the data. So using credit bureau data, I think is best practice. That's what very likely all of you are doing. What we found extremely helpful is to add family relationship data. So by looking not only at the person's individual credit information, but also matching credit information from their immediate family, we could find that the algorithm is picking up this kind of description of the personal environment of the customer. So that was giving a beautiful boost for many of the models. The second item is around business affiliations. So I was fascinated how much Brazil is a nation of business women and businessmen, etc. And so many of them run their own companies. Now, analyzing these companies is very worthwhile. So you find huge differences in terms of industries. And I imagine that's particularly true right now with COVID-19, where some service companies are much more affected than, let's say, some manufacturing companies. So looking at these business affiliations is very interesting. Then you take the business entity and you can look at items like how long has it been around, how old was the person when starting to work for this company. But then you can also repeat this kind of exercise we have done for the families, and you could basically look at the other people that are affiliated with the company. Maybe you have 3 or 4 people, and then you would look at their credit profile and basically find that this kind of network effect you found for the family, you can also find for the businesses. The third item is obviously any kind of internal information that you have about the customer might be extremely interesting. Now, this really depends on your business, so I'm not able to quantify. The fourth item is the SDK data. We spoke about it before. So it would require you to already use some smartphone apps to interact with your customers. But if you do, there's technology in the market that you can relatively easily plug in that is helping you to extract information from the phone if your customer allows. And so this information, as I mentioned earlier, can be extremely valuable to profile them. Then the next item would be telecommunication data, anything around, so how large is your network, how often are you communicating with them, at what times of the day do you communicate, how many outbound calls, how many inbound calls. So all of that can be very interesting if available. And then finally, geographic information, describing the area somebody lives in, describing, are these like high rises, are these low buildings, what is the purchasing power in the area, how about the risk performance. And I actually have a very interesting chart there that describes or illustrates well the power of geographic information. It's something from a project we worked on back in Germany. And so there was a telecommunication company having a bit of a trouble with e-commerce fraud on their store, and we could identify a certain hotspot where everything was happening. And then once we started to geocode the address and put it on a map, we got this picture which indicated that the fraud issue was not a problem of the larger city neighborhood. It was a very, very specific problem of a few roads. So you could see that all of these fraud cases illustrated by bubbles over here were nicely allocated around certain streets. And so it turned out that basically the delivery drivers of the delivery company were involved in this kind of fraud. And so once we understood the geographic pattern of the risk problem, we were able to point to this and help to solve it. So this gives you an idea that geographic information and plotting it and understanding distances and radiuses can be very helpful for scoring. So now, looking at all of this, in additional data, incremental data, you could layer into your existing credit model. We found that we could maybe achieve something like a 20% increase on the predictive power, which we measured on the area under the curve. So just, as something for sizing. The second item you would want to look at is, so once you have identified the data you would like to work on, you would do some feature engineering. So you would try to extract from your data the pieces of information that you want to make available to your scoring mechanism. And so we spoke earlier about the importance of transaction data. And so this transaction data you might have to summarize into snapshots. And so typically what companies do, or what data scientists do, is then they will take the data and then they say, okay, so I take 30 days, I take 30 to 60, 60 to 90 days. So they're building these kind of, expert rule buckets. However, nothing tells you this is a useful way to summarize the data. It might be that you're actually losing information by bucketing it in the wrong way. And so we did some work around using algorithms to summarize data in an automated manner, in a statistically optimal manner. So you would summarize the data into certain ways, and you would automatically generate KPIs. So you would calculate like the minimum and the maximum and the average, these kind of things. And so out of this, we observed maybe a benefit of 5% of the AOC. So not as much of the data, obviously, but maybe something still you would like to address. And then, last but not least, the scoring algorithm itself. I think this was a little bit of a surprise. Typically people would say, oh, it's all about the data, don't worry, if there's information in it, the algorithm will pick it up. So I think largely that's true. However, in machine learning, you had such big changes over the last few years that it's really worthwhile to look at like the latest technology and benchmark it against your traditional algorithms. So let's say if you are using logistic regression today, there's a fair chance you're losing out on a lot of performance of your algorithms because you can't really capture interaction between variables. Your model might not be as good at capturing nonlinearity, etc. So actually, we were surprised how big the difference would be. It was something like 25% of AUC increase. And having said that, of all of the things I've listed here, this is maybe the easiest thing to test because you might have your sample ready. So why don't you give it a go and you just try the latest that's available in machine learning. So I think that is basically it of credit scoring. So a few observations from when we worked on credit data in Brazil and what we got out of it. Now, once you have your beautiful credit scoring model, it's going to allow you to rank customers according to your risk. But then you basically bump into the next analytical problem. So how do you use your credit score to have a profit optimal credit decision strategy? So this is what I described by this slide, from credit scoring to profit scoring. So credit scoring is all about risk. So the question is, how do you connect this kind of risk estimation to a profit strategy for your company? And so what many companies do is they take the population, they would calculate the credit score, and then they would have a certain kind of distribution of the scores. And then you would go and test for each individual potential cutoff score. So what is my profit going to be? And what you can find over here as a visualization is that as your cutoff score increases, you will see that you capture more and more of your good customers because of the underlying population distribution. But then at some point in time, from the cutoff score, your profit starts to drop. So you would want to pick exactly this kind of cutoff score in order to optimize your profit. So that is typically what companies do. Now, which is, I think, a fair approach. However, it's something you do on all of your customers. So in average, it's right. But on the individual customers, there might be more intelligent things to do. Now, if you think about the idea of credit scoring, it's basically saying customers are different and you can identify, statistically valid differences and then treat them differently. So why should that be different when it comes to the profitability of a customer? So you would want to maybe use the credit score as a risk measure for your customer, but then layer in additional pieces of information. And so typically these kind of informations would be customer acquisition costs. So if I acquire this customer, how much is going to be? And the price might actually be quite different depending on your commission scheme, if you have to provide subsidies, etc. Then the next question is, so if I activate this customer, or if I lend to the customer, what is his vintage curve? Is this customer going to stay with me for a long time, or is he going to default very quickly and then he's gone? So what is the time structure of your default? And then once you have the customer and in a certain months on book, this customer is active, how much revenue do you expect that customer to make? And very often you can find that customers who have like a risky behavior often are just spending more. So you're buying more of your goods, they're maybe less frugal. So these might actually be more profitable customers. Then you have your revenue estimation for a specific months. You would multiply it by your profit margin, and it gives you an idea. So what is that profit of this customer going to be in this period if he does not default? And then you obviously have to combine it with, so let's say the default event happens. So what is my loss given default? So if you master these 6 components, you can basically turn your credit scoring model into a profit scoring model. And it has huge benefits because it might take your credit decisioning and move it just a little bit. So you just shift it a little bit to the side, but it increases the overall profitability of the customers you're acquiring. And then there is another thing that you can solve. So very often there is some kind of disconnect or divide between the risk management department and sales, where sales would argue, oh, you're missing the opportunity, this is really profitable, you should activate all of these customers. Well, if you're really including a profit estimation or a profit measure into your credit strategy, that discussion goes away because you can argue in financial terms with your peers. So I think profit scoring is, I think maybe one of the most interesting problems we worked on. I think very powerful because it changes entirely how you run credit, and it can have a huge impact on your bottom line. So I think very interesting. So now we've spoken about topics which are more relevant to underwriting. So I would like to move to an example that is typically used in fraud detection. It's about network analysis. So network analysis in literacy, you will also find under the term of a graph analysis. So a graph is basically a representation of how data elements are linked. So I have a simple example on the left side of my slide. So again, this was some kind of e-commerce data we're working on. And so you would have an order that was received. And this order had a delivery address. And then from the data, we would find that this delivery or this order had been submitted from a certain phone number. And then we found that exactly the same phone number had submitted another order, but for a different delivery address. And then this delivery address, interestingly enough, had an order that was submitted from a specific device. So we were using device fingerprinting to be able to give an identifier to a smartphone or a tablet or a PC. And then we could find that this specific device had submitted another order, which was again going to a different delivery address. So we basically found, using this graph, that here are 3 orders that seemingly are coming from different customers and not connected. But once we start to build graphs and to visualize and understand how these entities are connected, we could identify that actually they belong together. This looked like a fraud attempt. Now, what is a very simple example on the left is something you can build on a much larger scale and use for scoring and data mining. So we had the chance to work on like millions of records and build all of these very complex maps, like graphs and of interconnected entities. And so we would come across examples where you had one specific device that had submitted 30 orders over here, and then it was using a delivery address that was connected to another device which had another 6 orders connected. So we could identify that actually all of these orders were part of one cluster. And so this is something that gives you similar insights than this fraud hotspot I had showed you on the map earlier. Very interesting. And now, in order to use this, you can basically do 2 things. So the one use case typically would be in underwriting. So you would stop like a credit application or an order, and would then present to your credit expert these kind of graphs, just to have a look at it, if it's plausible that a specific order has connections through certain entities to all of these other orders. So that's one of the things. Then once you have a large graph like this, you can also use it as some kind of database. So you would be able to query it. You basically run like a statement against it and saying, okay, so I have this phone number, XYZ, tell me about the phone number. And then out of this graph, you would get information. Okay, so this phone number has X connections to other entities. From this phone number, it's going to be 3 data hops until you hit somebody who defaulted on payment or a confirmed fraud case, etc. So you would start to describe these positions of an entity in your larger graph. And then once you have extracted the information, you can make it available to a scoring model, like a fraud scoring model or a credit scoring model, to basically give a risk, like to give risk estimations to your individual data elements, something like an email address, delivery address, device, phone number, all of these items. So very interesting way of enriching your data set. And so that you could do for underwriting, you could do it for fraud detection, but it has also been used for churn prediction. So sometimes telecommunication companies are using this technique to identify the power users on their network that are talking to a lot of other customers, and so then they're granting VIP status to these customers in order to have them, to use them as a multiplicator about how great the company is. So plenty of use cases there. Moving on to collections. So collection is kind of, you know, the unloved child often in credit risk management. It's a process that is often, you know, kind of ugly. You have to chase customers. It's very expensive because you will need call centers, you will need big operations to reach out to customers. And so what many customers do, which is, you know, perfectly legitimate, is if the customer goes past you, they would grant a grace period. So the best thing that can happen to you is that the customer remembers on their own that they have to pay. And this is exactly what this partner of ours was doing. You had 43% of customers going past you, so quite high, but then only 12% flowing into the subsequent step. So the grace period was working well. Customers were remembering to make their payment. Now, for those customers who did not remember, there, you know, are options for outbound communication. So you send text messages, WhatsApp, you do outbound calls. Then at some point in time, you start suspending customers. Maybe then you have another way of suspending them, and then finally you cancel them. So you have this staggered sequence of steps over time. Now, there's one problem, because a part of your customers is going to learn what this process looks like. So you will find that you have a certain share of customers who are just waiting for you to suspend them because they know this is actually when I have to pay my bill. Everything before then are just reminders, free of charge. So they basically start gaming your process. And so then your whole strategy is flipping, because all these grace periods you grant to these people are just a loss in cash flow because they're not going to pay anyway. They have understood how this works and they're abusing it. So now, what are the options there? What we worked on was a classification model that was basically looking at all of these individual cure points, and then we were building a model that was predicting for every customer what is the action that this customer is actually going to react on. And so you would find this customer will remember on his own, this customer just send a text message, but then this customer go ballistic right away because he's waiting for you to take harsh measures. So that would be a customer you would want to accelerate in order to get the cash flow. Now, there's one thing to it. If you interact with this customer, he will respond in a certain way. And the payment channel that the customer is using can have big influences on your costs. Ideally, your customer is going to go to the website, he picks his payment card and he makes the payment. That is cheap for you. If you're unlucky, this customer is going to call the call center three times a day to negotiate some kind of payment plan that he ultimately is going to break, or he's going to pay by reading the credit card number to your agent. So that's really expensive. And so this is something you would want to take into account as well. So you want to look at what is it that makes the customer pay, what kind of action, and if he pays, how expensive is it going to be? And then out of this, you can get the optimal balance, like the cost optimum for your collection strategy. And so this was something we worked on, very interesting work, quite successful. I think we moved forward $60 million, so quite a significant amount of money. So that's collection. I guess I could keep talking about all of these different use cases. I think I always keep getting excited. Now, in the favor of time, let me give you a quick overview, like an outlook and a summary. So thinking about machine learning, as I outlined earlier, I think these are really good times because all of us benefit in the increase of computing power and move to digital processes. So actually, if you think about business operations, what kind of complexities there are plenty of ways how to optimize it. The second item is about lending. So one thing that is interesting about lending is we have this fintech technology. We have apps and customer self-service that have allowed many companies to enter the market for financial services. But even that the acquisition costs of customers and even that the customer servicing costs have decreased so much because of technology, the loan pricing has not really improved. Loans are still not much cheaper than they were a few years ago, even that you are self-servicing. You're not even asking for resources from your local bank. So these fintech companies, I think, have done a good job at basically installing themselves with a lower cost base, while just playing the pricing that already was in the market, which then, however, means there is still opportunity for kind of price leadership and growth in market share if you master risk. So we think this is really the one thing. Technology is available to many. Now it's all about managing the risk. Now, what is motivating us to come to Brazil and to work with you is that we believe there's still plenty of opportunities as financial inclusion is still at an early stage. Compared to other markets, still you have large segments of underbanked customers. We believe there is going to be healthy growth for everybody if these customers move into banking and financial services. The good news is that with some ways to work with alternative data and with unstructured data, there are ways how to do it. So long story short, we believe in Brazil and we're looking forward to working with you. Thank you very much.